Good afternoon to all of you, and welcome to the Smart Grid Educational Series webinar for October 2013. Today's webinar I'm dedicating to the victims of the Loma Prieta earthquake who passed away some 24 years ago. We had a major earthquake here in the San Francisco Bay Area on October the 17th in 1989. And I wanted to share some of the pictures with you to show you the magnitude of this earthquake and how much damage it caused. So here we have a picture of the Highway 880, the upper deck, and how it collapsed. It literally pancaked over a mile in the downtown Oakland area. There is another photograph here in the Marina District where we had extensive damage to some of those vintage buildings that are very close to the bay facing Alcatraz. Then we have so this has been quite a tragedy for San Francisco Bay Area, and for the last 24 years there have been several upgrades being done to the buildings, the bridges. You may have heard we have a new section of the Bay Bridge between Oakland and Treasure Island for that exact same reason, because a future earthquake of magnitude 8 or greater is possible in this area, and that bridge would not have been able to sustain it. So we built a new bridge that opened at the Labor Day weekend this year to help us be more secure in future earthquakes. And there have been many retrofits of buildings across all the major downtown areas of Oakland and San Francisco and San Jose. And at any time, if you come and visit the Bay Area, you would see all these upgrades being done. This is a very good intro to our presentation, because today we are going to be hearing from Dave Riley, who's an associate professor at Penn State University, about the GridSTAR facility at the Navy Yard. The GridSTAR facility has been established with DOE funding and with partnerships from Penn State and a variety of vendors in the private sector, and now it is in its 4th year since it started. And part of its purpose is to look at energy efficiency, to look at how to build buildings and how to build a variety of facilities, and then also how do you manage energy in an electric grid, especially on the last mile between the substation and the customer prem, and how do you protect against the type of outages that can occur in major catastrophes. I showed you just an example. It took parts of San Francisco several days for their electricity to be restored. And this is where the concept of microgrids comes in, that if you had renewable energy and you had storage and you could establish microgrids, then you could have an opportunity to have availability of electricity during these natural disasters, as I have just shared with you. We have in Dave Riley a very innovative person, a person who has worked extensively in the public and private sector, helping bring out the most creative, innovative type of technologies and business processes and also construction techniques. And he'll be sharing that experience with you as he describes this GridSTAR facility. He's also, as I said, an associate professor in the Architectural Engineering Department of Penn State University, and I have the privilege of working with him and his team at the Philadelphia Navy Yard. I'm not going to steal his thunder, so I'm just going to let Dave take it over. And at this time, I'm going to move the presenter ball to you, David. And all you have to do is move those horizontal arrows at the top, and you can move from one slide to the next. So with that, Dave?
Well, thank you, Irfan, and I very much appreciate the opportunity to address some of the representatives of this broad community today, and also I've been very appreciative of the chance to get to know Irfan over the last 6 to 9 months, and appreciated his wisdom and depth that he's brought to our project, as well as the opportunity that he brings to work together. And I'm excited to share some things that we're working on today, and also to hear your questions and feedback about this this effort at the Philadelphia Navy Yard. I'd like to share today a little bit about how this project came to be. I will talk about some of the physical facilities that we have in progress, and some of the educational goals and programs that we've set out to create. And then I'll conclude with some of the early success stories and that we are experiencing, and that are hopefully a sign of things to come. So this particular audience is well versed in the challenge that we face. Myself, being an architectural engineer with a background in construction, was fairly new, and I bumped up into this the challenge that our grid represents in a path that started with the need to identify different energy strategies, the need to build buildings more efficiently, and to deploy renewable energy. And it was through those early efforts that I became aware of the challenges that we face with respect to the energy industry, and I learned more about how the grid works, and the physics of the grid, the economics of the grid, as well as the challenges that the deployment of renewables were going to face. And it became very clear to me that as we sought to create a resource center in this topic, that we needed to have some breadth across a variety of topics, including energy distribution, the advanced metering and control of the grid, the issues of cybersecurity, of which Irfan has really introduced such great expertise, knowledge of distributed generation and the unique forms of interaction that combined heat and power and wind systems, solar systems have with the grid, as well as this emerging and increasing demand for electric vehicles. That all of those dynamics accumulated to the need to have a systems level understanding of the grid, and not just pick one individual topic like solar energy deployment, which was my initial thrust. We needed to look at these things in concert. So some of the questions that we began to ask at the outset of this project is, or include, how can we build a systems level understanding across different disciplines? So we have engineering challenges, but we also have construction and maintenance and operations challenges, and all of those audiences need to build a systems level understanding of new approaches to managing energy and the grid. We also have campuses, building owners, utilities facing some challenging decisions, and we would like to become capable of helping inform those decisions. And this is where we did choose to operate in proximity to various customer prems, as Irfan states, but how can we support large campus facility owners, residential communities, regional municipalities, and their deployment of stable microgrid or grid strategies that would be supportive of their capital and business goals. We also are quickly and broadly interested in the the skill gaps that exist across the professional and the skilled workforce that will inhibit the growth of the grid. I'm sure many of you are attuned to the demographics of power system engineers in the United States in particular. We have not attracted a lot of new blood into that field, and many utilities have a workforce that is increasing in its mean age, and we haven't exactly backfilled with all the talent that we need to maintain our grid, let alone the creative and innovative workforce we're going to need to expand and grow the smart grid. And another area of focus which we have zeroed in on is instead of component technologies and optimization of individual technologies, we would like our contribution to grow in the field of control strategies and simulation methods that inform decisions as opposed to the cultivation of new technologies. So we're not in the business of microelectronic, microprocessor development or even software development, but rather in control strategies and simulation techniques that can help inform decisions or the development of controls for grid systems. So these questions and observations have helped inform the mission of the GridSTAR, and what I'll do today is share some of the progress that we've made in pursuing these objectives. But our mission is to be an education and research resource for smart grid technology, policy, and business practices. And we view that in particular as a regional resource, but hopefully we can make a broad impact and provide some unique contributions nationally as we look to build more learning communities that are trying to respond to the smart grid challenge. Our first objective is to build a physical smart grid experience center, and I'll share some of our progress later in the webinar. We also had a goal to build educational resources in critical smart grid topics. We have a partner and close relationship with the electrical contracting industry and the IBEW, and their workforce infrastructure and curriculum development training expertise were included in the DOE proposal that we wrote as a vital national deployment channel that we would take advantage of, and they've been great partners in this effort. And we also want to be able to foster integration of manufacturers and tech providers in the development of solutions, and that last one is likely to be one of the areas where we see, a long-term but only emerging contribution. We've made strong headway on the first three objectives, and we're only now entering the space and seeing some success in on the fourth objective. There's quite a few partners that we've been able to bring to bear on on this project, and one of the things that I'm really pleased to share is that on this project we enabled a lot of different types of individuals and organizations to contribute and provide their expertise to what they're good at across the different topics, and this list continues to grow, and we continue to seek ways to engage individual expertise as we grow. I'm seeing a question from Craig Lewis about considerations for architects as a targeted professional group, and I would say a resounding yes as we build capacity, because we're increasingly understanding the contribution of the physics and efficiency of buildings as assets on the grid or as potential ways to reduce overall risk. We're very excited that the Green Build Conference will be in Philadelphia in November, and we have a tour scheduled with that audience, and the architectural and engineering profession is very tightly connected to our department in architectural engineering where we're housed. So I hope that responds to your question, Craig. Moving on to some of the strategic thrusts that we chose to focus on. So there's quite a lot of educational topics that you could pursue across the smart grid, and one of our initial areas of centered effort is in fundamental literacy. So through the development of content that can help us all be on the same page with terminology and issues, to help us be more informed in our professional interactions, and that fundamental literacy as a learning objective was the first that we approached as we've added new programming and levels of expertise. For example, the workshop series that Irfan has put together and that we are now supporting the rollout. We have an opportunity to work on very specific and focused topics, but our overall thrust to date has been in fundamental literacy. We also very much intentionally pursued demonstration of smart grid technologies in a living laboratory environment, and we found increasingly, particular with electrical technologies and systems, that there's a real benefit in experiencing these technologies firsthand and feeling and seeing live data from live systems, because it's a very esoteric topic for those who aren't electrical engineers or physicists who can kind of visualize these dynamics. So this living laboratory environment was very important. We also have a thrust in the deployment of renewables in a manner that integrates energy storage. So you'll see a theme and a thrust in some of the initial accomplishments of our experience center in that space, but pursued at various scales. And as I mentioned, you know, modeling and communication systems are a place where we've tried to pursue an area of contribution, and as such, microgrid modeling and security simulation and controls are a place where we hope to make an inroad and a contribution to support good and informed decision making in that space. So unless Irfan suggests that I add or amend, what I like to do is move into a description of our physical headquarters at the Navy Yard.
I think we're good. Please go ahead.
Thank you. I would hate to talk for an hour and have people tune out after the first 5 minutes, so thank you for that. But one of the unique features of this project, and this was a real unique experience for me personally, but also for Penn State, is we chose to launch this center and several other energy centers not at our main campus in the middle of Pennsylvania, which is farmland, or even any of our Commonwealth campuses, but to do it at the Philadelphia Navy Yard. And for those who are familiar with the BRAC process, the Navy Yard was one of many Department of Defense facilities that was turned over to private ownership. And it's now deep into that process, but the Navy Yard is owned by the Philadelphia Industrial Development Corporation, and they are critical partners in this process. One of the really interesting aspects of this project is that shortly after we were awarded, the PIDC was making a decision to either retain ownership of the grid on the Navy Yard or to sell it and essentially turn it over to a utility. We strongly encouraged them to retain that ownership, because what they really have is an unregulated grid. It's a proving ground and a test bed that we can deploy and experiment in a manner that is a little bit more nimble than you would if you were in a direct utility environment. So PECO, which is the utility, provides power to the Navy Yard, but their ownership of the physical resources ends at the gate. So we essentially are building this smart grid resource center in the middle of an unregulated grid. the grid itself is fairly robust, but also aging. The real carrot of opportunity is that they have growth at the Navy Yard. Increasingly, tenants are investing. Urban Outfitters was a great anchor tenant who consolidated all their efforts in the U.S. And in the region at the Navy Yard. And there are still Ocker Steel ship production, and the Navy is still a tenant. And currently, in 2013, they crossed the 10,000 employee mark. So over 10,000 people now come through the gates every day to work. And because of this draw, they're experiencing growth, but also the need for additional power. So they have a need to invest in the improvements of the grid, and we'll be able to be a partner and to be a part of that as it happens. So the significant investment that's coming in the grid that we'll be able to be immersed in as it unfolds. In addition to that, we have at our own campus been exceptionally fortunate to have a set of facilities operations expertise in power systems management, and we have built a pretty resilient grid at our main campus. We, as many institutions do, have many mission-critical facilities and research experiments for different investors that need to keep running. We have a fairly good approach to managing our own grid, and this brings us some expertise. Some have said that our Penn State grid at our main campus is about 10 years ahead of the Navy Yard's grid, but at least we are having a frame of reference and some additional expertise that we can bring to bear on the project. And Penn State is currently the technical advisor to the PIDC in the development of their grid. So some of the other interesting features, the 1,200-acre site of the Navy Yard is actually bigger than the downtown city proper of Philadelphia. There's over 350 buildings, and I mentioned some of the diverse tenants, and those tenants continue to grow. Penn State is currently renovating one building and also building a new classroom and conference facility at the Navy Yard. And they're currently projecting a pretty significant growth in their power requirements should that development continue at that pace, and there's every sign that they expect it to. What I'd like to share a little bit more about is the physical facility to which we are calling the Smart Grid Experience Center. And there are three phases of our physical development at the Navy Yard. The first phase was an investment in an upgraded power infrastructure where new transformers and switches were built, and a plug-and-play network was developed off of one of the main feeders in the Navy Yard. The second phase included the instrumentation and build-out of our physical location at the Navy Yard, which is a small site but encapsulates a variety of different components, including an instrumented commercial building, electric vehicle charging infrastructure, the modular and highly insulated smart grid residence, an indoor-outdoor training facility, advanced metering and revenue grade metering infrastructure. There's a community solar project that is in the works, as well as a grid interactive utility scale energy storage demonstration piece. And I'm just going to share a little bit more about some of those individual components. The residence was a project that was born from some of our research trajectory at Penn State in smart, affordable, and sustainable housing, and also through some of our partners who have built smart grid compatible and solar homes with battery backup systems for quite some time. But this particular residence was a way to demonstrate the value of the modular construction process in building a smart grid compatible home. So CertainTeed was a deep partner in this project that helped design, installation systems, and materials that would build a very efficient home. One of the benefits of a very efficient home is that it can ride through grid outages or even demand response type events without creating discomfort in the home, so it has the mass and the inertia to allow utilities and thermostats, even some appliances, to be turned down or turned off without any impact. It has a integrated solar photovoltaic and solar thermal systems that supply the thermal and electrical supplies. It has a grid interactive battery system that has demand response capabilities. The lighting controls, thermostats, and hot water heaters have the ability to also respond to a signal from the grid. And the partners that we work with currently can choreograph those types of signals across hundreds of homes to accumulate to a powerful impact on the grid. For example, the water heater, there's a preheat water heater in the structure that is part of a pilot program that is using water heaters to balance wind farm energy production. And the third coil in the water heater that allows the dumping of unwanted generated electricity in off-demand times into water heaters as a way to put it to good use. And the home also has an integrated electric vehicle charging system. I'm a proud driver of a Volt and a proud owner of a new electric motorcycle, which I'll also be showing off at this station. But the compatibility of electric vehicles and solar and efficient homes is very strong, and we wanted to help underscore that point. The energy that is saved or generated at a residence is actually worth more to a homeowner displacing gasoline in a car than it is on the grid. And we think it's very important for homeowners to consider an electric vehicle in their overall energy and transportation systems. The demonstration facility has a flat and sloped surface for different types of solar system installation and demonstration, so we can, for a variety of audiences, immerse them in the building and commissioning and testing of solar, photovoltaic, and thermal systems. And this is also partially financed by a solar instructor training center that we also have headquartered at the same facility. The main goal of this is to take instructors from the IBEW as well as community colleges and universities and empower them to integrate solar into their curriculum. And if they want to bring their students to this facility for the hands-on component of their courses, they will be welcome for that. There's a weather station associated with this facility, and the ability to do training both indoors and outdoors, so it's kind of a less pristine and messy space for people to get their hands dirty and experiment with these actual technologies. And not all for training and installation purposes, but even just having students assemble systems and have a chance to work with them will make them better designers, better consumers. So we've got a great set of resources that allows us to put these systems together and allow different audiences to interact with them. I'm very pleased to report that just yesterday we brought online a 150 kilowatt-hour grid interactive storage system. This is a lithium-ion battery system that began to operate in the PJM demand response frequency regulation marketplace yesterday. This was developed in collaboration with a company called Solar Grid Storage, who is a real contributor to economic and financing expertise, and they actually created a power purchase agreement to help bring this storage device online, and they are now rolling out multiple solar integrated storage projects in the region. This particular smaller device blazed a trail for them and their organization, and with PJM that is now opening up there are opportunities for them to pursue other projects, and all that are economically viable. They're not grant-funded demo projects. They're building grid interactive solar systems that are economically viable with a return on investment. The electric vehicle infrastructure includes several different types of chargers. One of the challenges of electric vehicles is they can pack a punch when they are plugged into the grid. So understanding different types of charging patterns and the variable economics of different topologies of chargers is something that really is perplexing both fleet owners, car makers, and consumers. So we'll be able to demonstrate and learn from that. There's a local company that has a NSF SBIR grant for a vehicle-to-grid pilot, and we'll be working with them to support their research and also be a training site for the electric vehicle infrastructure training program, which was developed to support the qualified installation of electric vehicle infrastructure. We're also going to be building a future phase of work that will include the grid interaction of the two buildings that Penn State will own at the Navy Yard. So we're currently renovating Building 661. This will be the future home of the Energy Efficient Building Hub, which is another one of the DOE centers that is headquartered at the Navy Yard. And in addition to that, we are building a new building from scratch, Building 7R, which will include training spaces and classrooms, and will be an all-electric building and fed with the geothermal energy system and heat pumps, and will also include a microgrid demonstration system. And I will say a little bit more about the features of that particular system. But the Building 7R will have a microgrid system that will have at its heart a 3-port DC coupled inverter that's built by Dynapower. The initial configuration of this will have 1 port dedicated to the solar energy production on the roof, and it'll manage the deployment of that DC power. It will also allow us to serve 2 different formats of energy storage, lithium-ion format battery as well as a lead-acid format battery, and we'll be able to choose between the second port which one we're serving at any given time. And the third port will be focused on supplying DC power directly to some loads in the building, the DC rapid charger or some DC mini-split systems. The controls for this device will be integrated with the building automation systems, the lighting and temperature controls in the building. It will have a separate AC port that feeds a critical load panel, and that will be used for servers. And in addition to that, the control system will be integrated with the PJM demand response market. And the main goal of this particular system is not to serve a particular load or backup power requirement of the building, but rather to demonstrate multiple modes of operation of a commercial building scale microgrid. A lot of folks have asked, why are we doing this? What's the point of this? But it will allow a few things to be demonstrated. One of them is that building owners often invest quite a lot of money in backup power supplies, either in large battery banks or generators, and that capital investment is basically made in hopes that you never need to use it. This system will provide the same functionality as a backup power supply, but it'll generate revenue from day one. And that economic dynamic alone is one of the main drivers for this particular investment. In addition to that, there aren't a lot of systems like this in place, and the controls and programming of this device are very challenging, but quite feasible. And we are building this to gain our own personal experience with this, along with the partners at Dynapower and Pacific Data Electric, who are helping to put this project together. So that will kind of conclude the presentation of the physical systems that we're putting together at the Navy Yard. The layers beyond that will include, of course, the upgrades and advancements that the PIEC makes to the grid at the Navy Yard in response to their tenants and increasing demand. The other infrastructures will be the case study projects and the work that our partners do outside the boundaries of the Navy Yard. But what I share today is the nucleus of our physical learning and research environment. So I'm going to pivot to talk about some of the educational resources that we've tried to build and talk about how they're related and hopefully will contribute to being a good resource around the smart grid community, as well as to attract new talent and help people advance in their careers in the pursuit of the smart grid. There are 4 programs that I'll share, including the webinar series that we're part of today. Irfan's been kind enough to integrate the series and the past accumulated recorded workshops, as well as the new recorded workshops in the future to park beside the resources. We have developed a series of online courses and blended learning workshops that are also being rolled out through Penn State. Irfan has also assembled the Cytor Energy Academy and put together a great vignette of 2-day workshops and very powerful national experts that will be capable of delivering mastery-level education on very specific topics. And we are very happy to be planning a rollout of those workshops in 2014 that will be located at the Navy Yard. And our final effort is the development of a graduate certificate at Penn State, and I'll share the details of that and how it fits in. So the webinar series, which we're being a part of today, is probably fairly well known to many of you, but we feel that the breadth and overview topics that are generated here are a great resource, and we've recently made them available and linked directly to them on our website. We'll be helping to promote that series and make it a strong part of the resources we draw attention to as we look to serve the smart grid community. The project and a 4-part online course series that we have offered now on a trial basis, and now are rolling out on I think a more consistent basis starting in 2014, is a 4-part online course series. And we also expect these same courses to be offered in shorter face-to-face and blended environments, but that build upon each other, with part 1 focusing on overall understanding of electricity markets and the challenge of the grid. So this helps those who've heard about the smart grid and are participating in related industries to develop a good background and foundation in the economics and businesses that are associated with the electricity market and the grid. The second part discusses smart grid technologies and strategies that are going to be important to that build-out, including advanced metering infrastructure, cybersecurity, and topics like that that are paramount to the development of the smart grid. The third focuses on distributed energy generation, and specifically solar, wind, and combined heat and power and their respective interactions with the grid. And the fourth, dedicated to smart grid systems and microgrid technologies, vehicle-to-grid strategies, energy storage, et cetera, that will play a role in ushering in the development of a smarter grid. The technical workshop series that I referred to has been assembled by Irfan and his partners at SciTour, but he has brought together a virtual who's who in the smart grid with a very broad set of topics, including transmission, distribution, end use, energy efficiency, and energy markets that address a wide variety of topics. But I think as I pointed out, has a strong focus on cybersecurity, data privacy, data integration, and these are topics that as we encounter those who are beginning to operate in the smart grid space, this is one that they're now realizing that they need to pay more attention to. A lot of microgrids and energy storage projects, for example, being developed by utilities or in the military, where there's physical firewalls between those systems and the internet. But as these systems are deployed more broadly, they're going to be very susceptible to more complex cybersecurity measures and data integration measures. And Irfan's expertise and the suite of specialists that he's brought to bear are very terrific in this space. So these two-day workshops will be offered at the Navy Yard and also, I think, increasingly made available for in-house audiences as a particular company or utility would see the value in these topics. We're looking forward to making them accessible in our region. And I'm going to ask if Irfan would like to amend my characterization of this workshop. This is something that he worked hard on in advance of our introduction to him, but I hope I did it justice.
Dave, I think you did a wonderful job. I would just like to add that these workshops are a little different than many of the educational forums that are available in our industry, where you don't get enough time to delve deeply into topics, and it's difficult to develop employable skills. So you essentially get a cocktail party knowledge of a subject with the period of time and the scope of many of these forums. So in looking at the industry and looking at these educational programs for a few years, I reached out to these subject matter experts and said, how can we do things a little differently so that we create a level playing field with concepts in the first part of the workshop, but in the second part, get involved more deeply into how to apply those concepts in real problem solving, so that the attendees of these workshops can take those skills and go back to their workplace and start applying them. Or if they're looking for careers in smart grid, they can learn from these workshops and get a meaningful job working for a utility or a vendor or a trade association or another stakeholder group. So that's the key distinction between, I'd say, this type of workshop and the kind that you're seeing from standard educational forums in the industry. Back to you, Dave.
Thanks, Irfan. I think that's a good description and an amendment. And I'll also say, as speaking from someone who's in the education business, we've really noticed some shifts, and one of them is that there are a lot of people in the education space because of the buzz or the fear or the interest or even stimulus funds that were in it as a for-profit endeavor, and that's resulted in a real mixed market. What I liked about these efforts is Irfan's characterization of mastery-level outcomes, and that we're really trying to teach people how to do things. And increasingly, educational programming needs to lead directly to a business practice and something that's going to help people get a job or do their job better, or it's really not going to be justified as a way to spend time or investment. So that's what we're going after. So we're very excited about the rollout of these workshops and look forward to being a part of that. The third component that I'd like to share briefly is universities move fairly slow. We're not that nimble, but 4 years ago I was part of a launch of a Renewable Energy and Sustainable Systems graduate degree, and that program will also have individual certificates, and one of them will be in solar energy. But our efforts at GridSTAR have contributed 3 specific courses to this program in distributed energy management, commercial solar systems and microgrids, and the solar energy project development process. And these, coupled with some of the other degrees, we think will be a nice option for those who work in the powered energy industry but might not have a degree in that space and would like to work on that degree in their part-time while they're working. So we're very pleased to offer this, and this degree just went online this summer. Applications have started to come in, and we think this will be an important part of our overall contribution. And it's also in the sweet spot of what Penn State is geared to deliver in terms of educational programming. So I'm going to move into the final part of the presentation that I have today, which is to talk about what were some of the things that the GridSTAR effort does to advance the development of the smart grid, and how the activities will look in the future. So in addition to building and maintaining and inviting people to this physical experience center and hopefully continuing to offer useful courses and workshops, we are also creating a capability to support the actual development of the smart grid. So by demonstrating new technologies and systems in our own infrastructure or in other build-out projects at the Navy Yard, we'll be able to continue to support the commercial viability and proof testing of new technologies. We're also able, with the partnerships we've built and continue to attract, to support collaboration across sectors. We've made a lot of introductions across team members that have actually led to business partnerships, and we anticipate that continuing and look forward to attracting that a growth in that family of collaborators. We do have a test bed for manufacturers, to do demonstrations, and we have several manufacturers that are building systems and deploying them on a demonstration basis, in viewing the GridSTAR Center on the Navy Yard as a test bed. And finally, the next phase of development at the Navy Yard is an investment in an advanced metering infrastructure, and as that gets built out and built upon our initial control and metering infrastructure, we'll be able to evaluate different types of SCADA systems and cybersecurity protocols that are going to be needed at the Navy Yard to support that. So we're very pleased that Will Agate, who effectively runs the Navy Yard for the PIDC, has said that the GridSTAR Center will be the R&D arm of the Navy Yard power grid. So that recognition was very important to us, and I think it'll be the key to our ability to be magnetic in attracting collaborators, partners, and hopefully approach this development in a way that's a little bit different from the way, say, a national lab or a technology center might pursue it. We're trying to build a new environment to work because this challenge and the opportunity warrant a new way of working. So we're still cutting our teeth on exactly how that works and what it looks like, but it's been very exciting to see it unfold initially. So to share a little bit of our success stories, I mentioned that the energy storage system was the first successful commercial development of a battery in the frequency regulation market with PJM. There are multiple utility deployments in place already, but this was the first time a commercial company put a system like this online. It is compliant in the rapid response market, less than a 4-second response time through its proof testing and initial telemetry. As of yesterday, it has begun to generate frequency regulation revenue, And I mentioned it's blazed a trail for the partners on the team to deploy other projects, and ironically, in addition to this system officially coming online yesterday, Solar Grid Storage cut the ribbon on another project in Maryland yesterday, a Conterra project that was a solar and storage project, also developed through a PPA. And we see a number of folks rolling out projects like that. But the process knowledge and expertise that it takes to bring them together is very valuable, and we're excited to be able to share that experience in our courses and our programming. The Net Zero Energy Home included a variety of partners such as Lutron, Eaton Corporation, Certainteed, and Solar Grid Storage, and those folks are currently collaborating on a large home development that is being pieced together in New Jersey. So the vendors who partnered on this house, who worked out some bugs as well as some collaboration channels, and tested the ability to put some of their products on the assembly line or in the residential market, has really resulted in them able to pursue other projects. And I'll be looking forward to reporting the fact that these partners who came together because of the GridSTAR project are now collaborators on building entire communities of net zero energy homes. We did pursue and expect to receive LEED Platinum for this facility, and are looking forward to the Green Build Conference next month and a chance to show off this particular success story. I'll share one little tidbit about this project. The solar system, solar photovoltaics, are PV integrated shingles, and by installing the solar in the manufactured housing environment, the labor cost of the installation process can be reduced about 80% because you can work on a flat surface and not be working on a high steep 10-12 pitch roof. That innovation alone is a dramatic contributor to reducing the cost of solar out of the gate and making it more accessible on a wider scale. It was one of many interesting lessons, hundreds of little lessons that accumulated over the course of building this house. We were also very pleased that UNIRAC has identified our facility as a training hub as they deploy, as well as other large-scale solar providers, large multi-acre solar systems. The crew balance and racking techniques, prefabrication methods can make all the difference in terms of the construction time, the quality of the installation, and the overall labor costs. So we have the capability for teams to come and experiment with different types of utility scale ground mount systems and hone the design of their assembly process, crew size, and skill sets for different regions and climates to make sure that the installation process is efficient. There's concurrently a development of a community solar project that will be adjacent to the facilities that I've already shared. This will be used to demonstrate the community solar strategy, and in particular will be offered to current tenants of the Navy Yard who might not have the space or facility that's solar friendly. They'll be able to buy into this community solar project and essentially have a flexible ground mount PV system that can help defer their utility costs and allow them to be in the renewable energy marketplace, even though it might not be physically compatible with their structure. And again, the fact that this will be taking place in an unregulated grid, it would be very easy for the PIDC to demonstrate credit and compatibility of the community storage project on the utility bills of their individual tenants. And the community solar project and approach has some interesting economic benefits that are only currently coming to surface, and we're excited about this project and our ability to help contribute to an understanding of that approach to financing photovoltaic projects. And we've also already become, even though we're not quite finished, a destination. So trade shows and regional conferences have begun to schedule visits to the GridSTAR site in the Navy Yard, and we're really pleased that the choice to develop the GridSTAR Center at this location has paid off, in that in addition to what we're doing there, the overall activity at the Navy Yard, the success of the redevelopment efforts are creating a draw, and a lot of people want to go down to the Navy Yard and check out what's going on there. So we gave multiple tours for the Facilities Management Association, whose international convention was held in Philadelphia a couple weeks ago, and that was my first opportunity to give a formal tour of our facilities, and it was very gratifying after working on this for several years to have a captive audience and also see the questions and interest that it evoked among that group. I mentioned that Greenbuild will be in Philly in November. We've also got multiple tours scheduled with them. IEEE has scheduled a regional conference and workshop at the facility in November. And in December, the National Roofing Contracting Association has scheduled a workshop at our venue. And these are the kind of things that in traffic that we will find to be very important into the future. And we look forward to hosting other events and activities in this environment, and that will be able to add value to meetings and activities that are dedicated to the energy industry and the smart grid. I'll put in a little plug that we do have an open house coming up on the 30th of October. If you're in the region of Philadelphia during that time, we would love to show you our progress firsthand. The web address there, gridstarcenter.eventbrite.com, is a registration system that you can use to let us know you're coming. We will have a recognition ceremony around 11 o'clock, a lunch, and a workshop on the future of the smart grid, in addition to the fact that most of the vendors and partners who helped build the project will be on hand to answer questions about the different contributions that they've made in the overall effort. And we're really looking forward to this particular event. It'll really bring a lot of effort that'll be culminating on that day. So we'd be pleased if you're able to join us. If not, we hope to see you there sometime in the future. And with that, I'll draw my presentation to a close. I'd be very happy to respond to some questions, thoughts, or suggestions. We are in the early phases of this project and are currently in position to help respond to needs and craft the future strategies we use at the GridSTAR Center based on the needs that we detect in the industry. We do not expect to be a long-term DOE-funded entity alone. We want to be making sustainable contributions in the marketplace. And to do that, we invite your criticism, comments, questions, advice, and contributions. And I want to thank Irfan again for making the time and space for us to share our progress so far.
Great. Thank you very much, Dave. And as I give people online an opportunity to post some of their questions, I would like to provide a little bit of a background to GridSTAR and to give you some suggestions on how you could possibly contribute to this effort. As Dave mentioned, this is a DOE-funded project in which Penn State, with its partners, provided cost share to the tune of about $5 million. So $5 million came from DOE, another $5 million in cost share. So we're talking about a $10 million effort that has put together all of the things that you've seen in the presentation today. This is part of Department of Energy's effort to bring renewable energy to the forefront, because as we see our forecast for how energy is going to be produce the electric energy. A lot of the coal and nuclear plants are either being decommissioned, or just the growth of the demand for electricity is moving increasingly towards renewable energy. But how do we put renewable energy on the grid in a stable manner? This is something that DOE has been wrestling with for a while, and many opportunities are being provided with funding to go and research this. GridSTAR is one such effort, and there are many other efforts that DOE has funded. Now, we are in the 4th year of this project. There is infrastructure. There is, as Dave said, an unregulated grid. So you have a sandbox from the substation, distribution substation, all the way to the customer prem, with all the usual appliances sitting at the customer prem. You have the ability to test out protocols, whether at the FIMAC layer, network layer, application layer. You can test out business processes. You can even test out the policies that you're considering before you implement them in a region, because you can see the technological impact of those policy specifications. You can test things out in a systemic manner. This is where I'll distinguish from labs. In labs, you have a bench, you put together the best you can of your ecosystem, and you test components. But when you have real deployments, commercial deployments, production environments, there are many other systems that you have to consider. And there is a big leap from doing it at a lab bench level to going out to the commercial level. And this is where GridSTAR really helps bridge that gap. So you can test out your technologies in a larger context, see how the technology impacts all the other technologies that it's connected to, and how the system acts as a whole. And this will help reduce the risk, both financial risk and technological risk, for commercial deployment. This is the type of partnerships we are seeking as we move GridSTAR into the private sector, because we are looking for opportunities where you can bring some of your funding and some of your products, put them into this facility, which I would say is about 70% made and 30% unmade on purpose, so that you could plug in your technologies and see how it works. You can run use cases that you've come up with and see what its impacts are. Then you also have the ability to educate your workforce. If you have people who don't have that much experience in particular smart grid technologies, it's very difficult for you to bring in-house training. You have this opportunity to come and have them work as apprentices in the GridSTAR facility and learn firsthand, hands-on, through the training center, through the online courses that we have, through the workshops, as well as through the empirical work. Now, let's look at it from a smart grid larger perspective. If you look at how we're putting all of this together, you've got renewable energy, like solar energy, we have storage, and then we have highly energy efficient technologies in the house. We have a distribution network that will operate with DNP3, and there will be IEEE 1547 standard that will connect the renewable energy to this. So you can see that the popular protocol standards that we're considering out there, for which there are domain expert working groups working in NIST, for which there is work going on in DHS, ICS, JWG, for there's work going on in various other DOE projects, you have a very good way of testing those protocols out to make sure that the specifications that are being laid out by these various DUGs and other subject matter experts are actually being interpreted correctly by the vendors when they build technology. So we have a very good opportunity to test out how renewable energy will integrate with the grid in a stable manner. And we can demonstrate this at a small scale of individual solar panels, or going up to all the way, as Dave showed you, the community storage. So we are hoping that you could come to the open house or subsequently for field tours, because as you walk around and you see the various technologies and the way we've laid it out, you will see opportunities for collaboration. And we're agnostic to the stakeholder group. Everyone has a need, whether you are a utility, vendor, academia, we're open to all of you, even the regulators in the various states. We would like you to come and see what kinds of policies you're thinking about for this domain and how this facility could help you refine those policies. So with that, I will look for some more questions from the group over here. I see some comments from William Miller. It says, as GridSTAR gets into ADM, hopefully regulators look at California, who has, in a number of areas, have provided tax incentives. Regulators do not have any first-hand experience and do not realize how helpful those incentives for deployment of renewables and energy storage. Okay? And there is also concern that if power from GridSTAR project is fed to the grid, the local utility would impose a premium on the power generated. Dave, are you aware of any of this?
Well, I'm looking at different questions on the Q&A section, so I was conjuring up some responses to those. But I think the question with respect to policymakers and PUCs, we feel that the environment we're creating is one that will definitely help inform the development of new policies, and already has been helpful in assessing the impact of the introduction of the demand response marketplace and how that's being responded to and how that could be perhaps pursued in other regions. There was a second question. So we do have ambitions to, and policy makers sort of at the table currently, and we do think that that's a very important space to be informative. It's not just about technology; it's just definitely about policy implementation. Irfan, could you repeat the second question that was
Sure.
about the interaction with the grid?
Yeah, it says there's also a concern that if power from the GridSTAR project is fed to the grid, the local utility would impose a premium on the power generated. Right.
So to date, the local utility is aware of the different energy and energy storage deployments. The local utility is PECO. They are however, these contributions are fairly minuscule compared to the overall energy draw that PECO sees. But currently, they have not expressed an intention to take our current projects and impose any sort of penalty. On the contrary, the crafting of different types of rate tariff structures by the PIDC for different tenants is something that we're working with the PIDC on to help assess how tenants with unique load profiles or aspirations for renewables can be accommodated in a manner that's going to provide a good return on investment. For example, the Urban Outfitters deployed a Bloom fuel cell largely because they just had an aspiration to demonstrate that technology. But the process of developing a rate tariff structure and an interconnection agreement was confined to the Urban Outfitters and the PIDC, and didn't include extensive interactions or prospective problems and penalties with PECO. That said, as this project unfolds further, PECO and regional utilities are very important partners in sharing their perspectives and questions about the kind of experimentation and deployment projects that we're doing. And they will be at the table as we learn from our projects. I hope that answers the question or comment.
Yeah, I would just say, Dave, that at this point, we haven't really negotiated very much with the regional utilities in terms of what economics GridSTAR will play in the local utility service territory. It's more about frequency regulation and ancillary services up to now. And I think this is still work in progress.
So there's a couple questions in the Q&A box, Irfan, that I could respond to.
Yeah, please do.
So one of them is from Ashu with respect to programs available for smart grid technology entrepreneurs and startups. And we look forward to more of this interaction. I mentioned we have a local entrepreneur who started a small company that has a vehicle-to-grid control interface, and they wrote the GridSTAR project into their NSF SBIR project, and I think we'll be able to provide two things to them. The first is an infrastructure that can welcome the connectivity and experimentation that they need to do a proof of concept. Secondly, we can bring to bear different audiences to ask some early questions in their rollout of their ideas to help keep them on track and not make any silly mistakes that would really threaten the viability of their overall future. So in an infrastructure that could be a resource and help stretch grant dollars, but also in the types of advice and partners that we can help bring to bear to give entrepreneurs and advice that'll help them be successful. The next question is for Michael, who asked about the loads in the microgrid interface via the AC or the DC link. And this is one of the interesting attributes. I think you're referring to the microgrid system in Building 7R, and I'm just going to scroll the slides back to that particular system briefly. But the unique features of this particular system will enable loads to exist on the DC port or the AC port. So on either side of the inverter, this system has the capability to manage and interface with loads. And I hope that that answers the question. And David Katz asked a question about how do we charge for the use of the facility. We do that in two ways currently. In terms of just the use of the facility as a meeting space, we have an agreement that we ask folks to work with us to identify how and when they're going to use the facility, and we charge basically the value of the space to cover our costs of planning and management, and also offer support in meeting planning and navigating local catering, that sort of thing. The other way that we would charge for the use of the facility would be the inclusion of facility costs and infrastructure in research grants that could be used to both hopefully stretch grant dollars out, but also provide a environment to improve the quality of grant proposals and research projects with either the value of the Navy Yard location and its grid attributes, the value of the SCADA and revenue grade metering infrastructure, or the value of the education and outreach platform that we've built in addition to the physical facility. So all of those are ways that we would seek to generate some revenue from the interactions that might take place in this facility. So David, I hope that answers your question. And Dave asked if the presentation is available for download, and absolutely, I'll ask Irfan for the best mechanism to do that, but I think he typically posts the PowerPoint presentations as well as links to the archived video, and I've got no problem at all with making a presentation information available for that, and hopefully it's useful.
Very good. And Craig Lewis from the Clean Coalition is volunteering to be a partner with us at GridSTAR and is going to provide us some details on the Clean Coalition's Hunters Point Distributed Generation and Intelligent Grid, the DG plus IG project. So it apparently, according to Craig, it's very complementary towards the commercialization stage of DG plus IG. So I appreciate the offer, Craig, and we'll follow up with you on that. There were questions about which protocol standards we are using. I would say that up to now, GridSTAR facility has been mostly about demonstrating technologies or looking at the operability of various types of applications. And each vendor has provided their ecosystem in which, with some management, their appliances work. Going forward, as we will look for collaboration with utilities and vendors, my hope as the Strategic Innovations Director for GridSTAR is to start putting together standards-based systems at this facility to do testing of interoperability. And in that regard, there are some protocols that we'll be very interested in looking at. One of them, of course, is the DNP3 protocol for the distribution automation. So from substation all the way to the customer prem, applying it to sensors, applying it to the relays and switches. And also in some instances where IEC 61850 is being used, we will put that protocol and test it out. We will also be testing with IEEE 1547 for the renewable energy and how it integrates with the grid. So there we will be looking at the interplay between DNP and 61850 on the distribution side and IEEE 1547 on the renewable energy side. Then as we enter the home, we would be looking at Zigbee for the meter, connecting to some type of an adapter that would have connections in Wi-Fi, Zigbee, and home plug. And the home plug will be the one that we would look at to connecting with the EV charging so that the protocol runs on the same wire where the electricity runs. Of course, at the electric charging, SAE has a variety of standards that we'll be looking at, including the J1772 for the connector. We'll be looking at J2836 and J2847 for the communication between the vehicle and the charging unit. So there are a variety of protocol standards that we'll be looking at. My hope is to standardize around the Smart Energy Profile 2.0 for the home, the residential facility that you see in GridSTAR, so that we have a common information layer, and then we can have different FIMAC layers and below that stack, so that we have a very universal way of collecting data. Having the appropriate data to be able to take what we'd call actionable intelligence. You take data, you process it, and then you take the appropriate action based on the intelligence that you've derived. That's going to be key. So what I would like to say is, at the moment, we have individual vendors that are demonstrating their technologies. There is some level of integration, but there can be much more as we move to these standard protocols. Any other things you want to add, Dave, before we bring this webinar to a close?
I think that was a good summary of where we're at with respect to component technology deployment, but then the development of an infrastructure that will allow us to monitor, test, and also demonstrate SCADA protocols and cybersecurity. That is the next horizon that we want to pursue, and we're appreciative to have Irfan's advice in that phase of the project. I'll just again express my appreciation to have this audience, and I look forward to the chance to work with more of you in the future. Great.
William Miller had 2 additional points. He strongly recommends a course in critical thinking and review of the history of the grid and evaluation of future regulatory matters. That's one point. And then was asking if there would be a newsletter form from GridSTAR, and we will definitely have electronic forums in which not only will it be like a newsletter, but we will also start a dialogue online. And we're already in the planning of a forum like that for GridSTAR so that the larger community can be involved. I wanted to add just a couple of points before we conclude. One is that there are very good facilities for testing out protocol standards around the country, including Idaho National Lab and the Pacific Northwest National Lab and NREL and a variety of other facilities. So we're not trying to replace those facilities. I think that they're doing very good work, but we wanted to create a regional capability where utilities, vendors, trade associations, academia, and even national labs to a certain extent can come and work in this ecosystem that includes all the parts in reality. They're not just simulations or like little test beds. These are complete ecosystems in which we can test things out. So think of this facility as complementary to what exists in the country. And there will be need for those types of facilities, and there will be a need for the GridSTAR, and not to look at it in some kind of a competitive sense, because after all, DOE funds all of these facilities. So I wanted to make that point because we're coming into the market, we're offering something that sounds familiar, that has been around, but the differentiation I'd like to make is that we have more components all put together into a system, a complete ecosystem for the last mile from the substation to the customer prem, including many smart grid technologies that Dave Riley presented in this talk today. So with that, I would like to thank all of you. We are going to have a presentation by Steve Dawson. It's going to be coming up very soon. I'm going to send out the date and invite very soon for that. And we will continue this webinar series twice a month. We will have seminars and webinars as we've been having for the past almost 2 years. And we really appreciate the support that you're giving us. We're looking forward to hosting you at the open house on the 30th. And I really want to thank Dave Riley for a stellar presentation. I hope it has addressed a lot of the questions you've had about GridSTAR from the emails and other pieces of information you've been receiving. So with that, I'll bring this webinar to a close, and we look forward to having you in the next forum. Thank you very much.